Hi everyone, in this video we're going to take a look at another type of special right triangle called a 30, 60, 90 degree right triangle. Similar to the 45, 45, 90 degree triangle, there's a little pattern to it. I do find that this one is a little more challenging because the two of the side lengths aren't the same like they were in the 45, 45, 90 triangle. So let's jump right into it. In this 30, 60, 90 degree triangle, the length of the hypotenuse, or the one across from the 90 degree angle, is twice the length of the shorter leg. That shorter leg is always across from the 30 degree angle. And then the long leg is always that shorter length times the square root of 3. So that's just another way of observing it, is the short leg is some value, the long leg is that value times the square root of 3, and the long hypotenuse here, across from the 90 degree angle, is always 2 times that short leg. Don't confuse these two. It happens all the time. I see it all the time. A lot of times I see students take this number and just multiply it by 2 and put it on the long leg. The long leg is that number times the square root of 3. Let's get into an example. My first suggestion is always to redraw this diagram in the same method that, or the same direction, I guess you could say, as our diagram. So this is 30 degrees, 60 degrees. Across from our 30 degree angle should be the missing length. I'm just going to use the variable y, small leg. Across from the hypotenuse is 2 times that small leg. And across from our 60 degree angle is that small leg times the square root of 3. So let's fill this in here. Across from the 30 degrees is our value. I'm going to call it y. Across from the long leg is that value times the square root of 3. And across from the 90 degree angle, which is the hypotenuse, is 2 times that missing length. There's a reason why I do this, because when we go back here, look at what we have. We know this number 6, and I'm going to compare it to this 2y. So if I want to solve for what y equals, right here, I can create a little equation. So since you know the hypotenuse has a length of 6, you can write the equation 6 equals 2y. And when we divide by 2 on both sides, you will get y equals 3, right? In this case, our y, our small leg, when solving for x, right, this variable right here, x, these two will be the same value. So our short leg must be 3. And the best part about this is once you know your short leg, let's go back up here. Once I know this short leg, it's just multiplying by the square root of 3 for the long leg. So long leg equals x root 3, or I wrote y root 3, sorry. So since we know the short leg is 3, the long leg will equal 3 square roots of 3. That's pretty quick. That's a little put a typo there. That's pretty quick. All right, let's take a look at some examples though. I'm going to redraw my 30, 60, 90 triangle. Notice that it only says 60 degrees and 90 degrees. This other angle measure must be 30 degrees. Triangle angle sum theorem must add up to a total of 180 degrees. I can write this as x, 2x, and x squared roots of 3. Again, I'm just following the pattern of our triangle. Across from the 30 is the small leg. Across from the hypotenuse is 2 times that value. And across from the 60 degrees is that small leg times the square root of 3. And notice I'm drawing it in the same pattern. I know I'm using the same variables here, but just I hope you understand that this is saying 2 times this smaller leg. Let's take a look at what we have. I know that the small leg is 12, so this length is our small leg. We have 12. If I take the hypotenuse 2 times that small leg, then 2 times 12, which would be here, is going to be 24. And then if this is 12, this here is this number of the small leg times the square root of 3. So I'm going to say 12 square roots of 3. So following this pattern, 12, 2 times that small leg, which now is 24, and that small leg of 12 times the square root of 3. Let's look at another example. I'm going to redraw my triangle just so I can have the pattern. 30 degrees, 60 degrees, 90 degrees. I'm going to call this x, 2x, x squared to 3. Let's look at what we have. I know the hypotenuse is a length of 40. The hypotenuse should be 2 times the smaller length. So we can create a little equation here. 40 equals 2x divided by 2. X equals 20. So my small leg here should be 20. And now that I know that that's 20, our long leg across from the 60 degrees is that number times the square root of 3. So it's pretty quick. Once I know my small leg, I can say this is 20 square roots of 3. Let's look at one more example. Like before, I'm going to redraw my template, but let's try to draw the template almost exactly like the triangle it's given. This is my 60 degrees, this is my 30 degrees. This is where it gets a little challenging when you're rotating the different figures. So if you need help, take like another template that you've drawn and rotate it so you can visually see what's going on. Across from my 30 degrees, I'm just going to call it x. Across from my 60 degree angle is going to be x root 3. And across from my 90 degree angle is 2 times that smaller length. So again, looking at what we have, it looks like we have the long leg across from our 60 degree angle. Let's write an equation. 2 square roots of 3 should equal x square roots of 3. I'm going to divide by the square root of 3 on both sides. Hey, look at that. That will actually cancel out. So our small leg, right? Our small leg here should be 2. So I'm just going to put it on this diagram, 2. And now that you know your small leg, you can now find your hypotenuse because it's the 2 times the small leg. If I know the small leg is 2, well, 2 times 2 will be 4. Special right triangles can be solved pretty quickly. Really redrawing those patterns is very helpful. Rotating your paper to get these diagrams is really helpful. Just like in my last video, I showed a very brief explanation of where you may need to rationalize. That can be a little challenging. For example, what if your triangle looked like this? And you did not know the hypotenuse, you did not know the short leg. What if I said the long leg was 9? Well, right? Because based off our pattern, this should be x root 3 and x and 2x. You would have to set these equal to each other, then divide by the square root of 3. That means this length, the short leg, is 9 over the square root of 3, where you would have to eventually rationalize that denominator. Again, you can watch the videos that are linked in there for rationalization. But just to finish this problem without rationalization, 2 times the short leg is the hypotenuse, so 2 times this would be 18 over the square root of 3. Again, this is a more challenging